Hello everyone, my name is Aditi Devrani and today I'll be presenting my machine learning project titled Advertising Sales Prediction Using Multiple Linear Regression. The objective of this project is to predict product sales based on the advertising expenditure across different media channels and understand which advertising channel contributes the most to the sales. I began by importing all the required Python libraries. I used pandas and NumPy for data manipulation and numerical computations. Matplotlib and Seaborn were used for data visualization. Finally, I used skitlearn to build the multiple linear regression model and Yellowbrick to visualize the model's performance. Next, I uploaded the advertising dataset provided for this project and loaded it into Google Colab using the pandas read CSV function. This dataset contained information about advertising expenditure on TV, radio, and newspaper along with the corresponding sales value. I displayed the first few rows using the df.head and checked the dataset information using df.info to verify the data types and ensure that there were no missing values before proceeding with the analysis. To better understand the relationship within the dataset, I created a pair plot. The pair plot visualizes how each advertising feature relates to product sales. From this visualization, I observed that TV advertising has a strong positive relationship with sales. Radio advertising also shows a positive relationship, while newspaper advertising appears to have a comparatively weaker relationship with sales. These observations provided an initial understanding of the dataset before building the regression model. After exploring the data, I built a multiple linear regression model. In this model, TV, radio, and newspaper were used as independent variables, while sales was the target variable. After training the model, I examined the regression coefficients. The coefficient indicates how much the predicted sales change when one advertising feature increases while the other feature remains constant. From this result, TV and radio have positive coefficients indicating that increasing expenditure on these channels increases sales. On the other hand, the coefficient on newspaper is very small and slightly negative, suggesting that it has very little influence on sales prediction. I also generated a correlation heat map to measure the relationship between all the variables. The heat map confirms that TV has the strongest positive correlation with sales, followed by radio, whereas newspaper has the weakest correlation. These findings supports the observation made from the pair plot and the regression coefficients. Next, I performed feature selection to compare two different regression models. In the first model, I used only TV and radio as input features and calculated the R-squared score. In the second model, I used TV, radio, and newspaper together and again calculated the R-squared score. The R-squared value increased only slightly after adding the newspaper feature. This indicates that TV and radio alone are sufficient for achieving almost the same prediction accuracy, while newspaper contributes very little to improving the model. To evaluate the model, I divided the dataset into training and training set using train test split technique. I evaluated two different models using RMSE and R squared. Interestingly, the model using only TV and radio produced a slightly lower RMSE and slightly higher R squared score than model using all three features. This further confirms that newspaper does not significantly improve the prediction performance of the model. I then used the Yellowbrick prediction error visualizer to evaluate the model graphically. This graph compares the actual sales value with the predicted sales values. The most of the points lie very close to the ideal prediction line, indicating that the model predicts sales accurately with relatively small prediction errors. In the final part of the project, I explored the interaction effect between TV and radio advertising. I created a new feature by multiplying the TV and radio values together. This interaction feature helps capture the combined influence of these two advertising channels on product sales. After training the updated model, the performance improved significantly. The RMSE decreased to approximately 0.70, while the R-squared score increased to approximately 0.979, indicating a much better fit than the previous models. Finally, I evaluated the interaction model using the yellow brick prediction error visualizer. Once again, the predicted values closely match the actual sales values, demonstrating that the interaction model provides highly accurate predictions. This confirms that considering the interaction between advertising channels can improve the performance of a multiple linear regression model. To conclude, this project demonstrates how multiple linear regressions can be used to predict product sales based on advertising expenditure. The analysis showed that TV advertising is the strongest predictor of sales, while radio also contributes significantly. Feature selection confirmed that adding newspaper provides only a very small improvement in the prediction accuracy. Finally, introducing the interaction feature between TV and radio significantly improved the model's performance, achieving an R-squared score of approximately 0.979. Overall, this project highlights how machine learning techniques can support data-driven marketing decisions and help businesses optimize their advertising strategies. Thank you.